All right, let's look at the ODE, variation of parameters. All right, so number 25, use the variation of parameters formula to find a particular solution of the equation. All right, so I wrote down the formula here, so we're going to use that. All right, before we do that, we're going to have to find the y1 and y2. All right. So first thing is I'm going to look at the homogeneous version of the corresponding equation. So you have a y double prime plus 9y is equal to 0. Right? Homogeneous just means that the right hand side is 0. All right, then we can turn this into a characteristic equation. So we have a r squared plus 9 is equal to 0. Right? So this is going to have imaginary solution. So you have r is going to equal to plus or minus 3i. Right? All right. Then what we want to do is we want to find y1 and y2. All right. So y1 in this case. So it's going to be a cosine and sine. Right? So it's a 3i. So it's going to be a cosine of 3x, and I'm going to take y2 to be sine of 3x. Alright, so we found y1 and y2. Alright, so let's find the Wronskian. So we need the Wronskian for both terms. So Wronskian of y1 and y2 would be, right, so determinant. Right, so you have a cosine of 3x here. Then you have a sine of 3x. Alright, derivative cosine of 3x is a negative 3 sine of 3x. And derivative sine of 3x would be 3 cosine of 3x. Right? So determinant, so cosine of 3 cosine, so it's going to be a 3 cosine squared of 3x plus, actually minus with the negative sign, so it's plus 3 sine squared of 3x. Right? So if you pull out 3, then you see cosine squared of 3x plus sine squared of 3x. Right? So since using the trig identity, right, cosine squared plus sine squared is going to be equal to 1. So therefore, this is just going to be 3. All right? All right, then let's compute the first integral. So we have an integral. All right, so y2 is a sine of 3x. And f of x is just simply the right-hand side here. So this is the f of x in the formula. All right, so we're going to get, let's see, secant is going to be 1 over cosine. Maybe I'll write it as a 1 over cosine of 3x. And divide by Wronskian. Wronskian happens to be 3, so I'm just going to put the 1/3 outside. All right, so I'm going to use this trick. If you have, whenever you have an integral of g prime of x over g of x dx, and you can use the substitution to verify this, but this is just going to be a natural log of absolute value of g of x plus some constant c. All right, so we're going to use that, and we have to do a little bit of a tweaking here. All right, so we want to find the antiderivative here. We almost have what we want. Derivative cosine of 3x would be negative 3 sine of 3x. So I would like to have a negative 3 in front. So I'm going to multiply the bottom by negative 3. All right, so that way we don't change anything. All right, that way you have exactly the derivative of the denominator. All right, so antiderivative is going to be, all right, so the constant is negative 1 over 9. All right, so this is going to be a natural log of absolute value of cosine of 3x. All right, so plus some constant c, but we don't have to worry about that when you do the variation of parameters. All right, let's compute the second integral. All right, so you have an integral. All right, so y1 is cosine, so cosine of 3x over, all right, secant is 1 over cosine, so this is kind of convenient, 3x, and divide by Wronskian again, so 1 over 3 with respect to x. All right, so we can cancel cosine of 3x and cosine of 3x. You just get 1. So antiderivative is extremely simple, so it's going to be 1 over 3 x. All right, then we're almost done. So we know that therefore the particular solution yp is equal to, right, negative y1. So negative and the negative cancel out. So you have 1/9. All right, and then the y1 would be, let's see, y1 is cosine. So you have a cosine of 3x times natural log of absolute value of cosine of 3x. All right, and plus, all right, so you have y2 is sine of x, and then you have 1 over 3x, so it's going to be 1 over 3x sine of 3x. All right, so this is the particular solution using the variation of parameter formula. All right, that's it. I hope that this was clear.